All right, good morning, everyone. So for our next talk, we have Portia Burton, who will be giving a talk titled Know Thy Neighbor, Scikit, and the K-nearest neighbor algorithm. So please give a hand for Portia.
Hello, thank you for coming. This presentation is going to be on the K-nearest neighbor and Scikit learn. We're going to keep this presentation high level, so we're not going to get too deep, and most of this presentation will be based on the Scikit learn documentation. So for those of you who are part of upkeeping the documentation, thank you. A little bit about me. I'm from Portland. I'm the organizer of the Portland Data Science Group. We're basically a gang of people like visualizing data. We like analyzing data. Once a month, we have talks, and once a month, we have a hack day. I really love this group. I'm also volunteer of Hack Oregon. Hack Oregon is a civic organization that takes campaign data and makes it more accessible to the people of the state of Oregon. And I am also founder of the company PLB Analytics. What will we cover today? A brief intro to machine learning. We'll go over scikit learn. We'll explain the K-nearest neighbor algorithm. And finally, our demo will be based on the scikit learn package and KNN. Machine learning. What is machine learning? We've had many presentations during this PyCon that explains machine learning, but I'm just going to get to the core of it. Machine learning is basically when an algorithm learns from the data. It takes the data and it makes its assumptions. What does machine learning algorithms use this data for? Well, to give you a sampling, it creates predictive models, classifies unknown entities, and discovers patterns. Once again, this is a sampling of what machine learning algorithms can do. Today, we are mostly going to concentrate on the creating of predictive models and classifying unknown entities. This is my basic workflow in machine learning when I'm dealing with data. I spend about 70% cleaning, standardizing the data, putting it into Postgres, chasing stray commas away. 20% of my time is used to pre-process, train, and validate the data. And 10% is used to analyze and visualize my data. When I visualize my data, I try to use D3 JavaScript. It's a great package for interactive visualizations. And it's a lot of fun to use. Scikit learn. Scikit learn is basically Python's answer to machine learning. It's a Python machine learning package. Scikit learn is great because it has very good documentation. It is well written. And finally, it has a great data set. For example, the Boston housing market. Today, we will be making use of a scikit learn data set that's already part of the package. If you're new to machine learning and you're using Python, this cheat sheet is a great way to figure out or navigate the scikit learn package. First, you can figure out, well, what is your sample size? Do you have less than 50? Do you have 1 million data points? This is a good way to figure out what to do based on your sample size. And this is a great way for you to identify what exactly do you want to do. Do you want to classify, cluster? Do you want to do a regression? Or are you concerned with dimensionality reduction? That being said, it's very common for data scientists to use more than one algorithm. They can use several different algorithms in order to make sure that their results or their outcomes are to increase the accuracy. Many companies use Scikit-learn. I actually used to work for a company that used Scikit-learn, but this is not one of them. Evernote, I did not work for Evernote. Evernote is great. Evernote's a good way for you to organize your notes into notebooks. And a use case of Scikit-learn for Evernote is, are you a recipe? I don't know about you, but when I use Evernote, I have different types of notebooks. Evernote is a great way for me to keep track of my recipes, keep track of my friends, and keep track of work and documentation. So whenever I go online and I find a note, Evernote suggests which notebook I should put my note into. Suggesting of notebooks is a classification problem, and it implements the naive-Bayes classification algorithm, which we're not going to get into today. That being said, I'll just give you the formula. The naive assumption of independence between every pair of features, that's basically what it does. Supervised and unsupervised learning. In this session of PyCon 2014, I think many of the presenters who looked at machine learning did a really good job of defining what is supervised and what is unsupervised learning, and we're going to go over that today as well. Unsupervised learning is when your data points are not labeled with outcomes. So it's your algorithm that's actually finding the pattern of your data. Supervised learning is when your samples are labeled. Supervised learning can come in two different flavors, classification and regression. This is the theoretical model of supervised learning. In supervised learning, if you're making a prediction, your prediction's based on your features. So you put your features in, and the outcome is based on your features and your predictors. Remember, when you're coming up with predictors and features, keep your sample size high. You want to make sure that you have plenty of samples. But that being said, keep your sample size high. But keep in mind to keep your feature set low. The reason why it is instrumental to make sure that your feature set is low because you do not want to run the risk of overfitting. Here are some examples of how supervised learning is used. Handwriting analysis. I think we're all familiar with spam filters. All right. Next, we're going to talk about k-nearest neighbor algorithm. The k-nearest neighbor algorithm is considered to be the simplest machine learning algorithm. It is also considered to be a lazy algorithm, which means that it will not run computations on your data set until you give it a new data point that you are trying to test. In our demo, we're going to use KNN for supervised learning. And that being said, we have a little problem now where we can implement the KNN nearest neighbor algorithm. Problem number one. Let's say you have apples, those are apples and oranges, but you also have a mystery fruit. Our goal is to figure out what is the identity of the mystery fruit. So using KNN, we're going to set KNN to 3, which means we're going to look at the 3 closest neighbors. In this example, we have an apple and 2 oranges. So based on our closest neighbors, we can infer that our mystery fruit is an orange. When you're looking at the nearest neighbors, you're taking a majority vote. A majority vote can be done in 2 different ways. A majority vote can be given equal weight, where each KNN neighbor has the weight is equal. You can also set this parameter to distance weight, where each KNN neighbor vote is based on the distance, how far the neighbor is away from your sample. KNN uses simple Pythagorean theorem. It's something that we learned in middle school, and it's basically middle school math being useful as, as we're doing our research. Let's see. Downsides of KNN. Since there's minimum training, there's a high computational cost in testing new data. Another problem that you might encounter with KNN is that sometimes the correlation is falsely high, which means the data points can be given too much weight. Live demo time. Before we get into the live demo, I will tell you that we're using a data set from the Scikit Learn documentation, which means our data is going to be irises. For those of you who have taken a machine learning 101 class, classifying irises is considered to be a very common problem. It's typical. It's a typical data set. The iris data set actually predates Scikit-learn, it predates Python, and it predates most of us in this room. The iris data set was a multivariate data set that was created in 1936. It was analyzed by Sir Ronald Fisher, but it was gathered by Edgar Anderson. The problem that we're trying to solve today is we're trying to identify which type of iris that we have. We can identify which type of iris we have by measuring the length and the width of the sepal. For those of you, myself included, who need a refresher in terms of where the sepal is located, the sepal is below the petal as labeled in that diagram. That's something that I wasn't aware of until doing this demo. And to the right, you have 3 different types of irises. This is actually skipping ahead. Once we run our data set, this is going to be our result. This is the plot from our use case. The dots that you see is actually the training data, and the red, green, and lilac would be our test data. The red, the green, and the lilac is actually our decision boundaries. And if we move over to our second slide, the colors refer to the different types of irises that we have, the different species. Okay. So I am going to let's see, give me a moment. We're going to use IPython. There we go. IPython is great. IPython comes in 2 different flavors. You can use IPython in the command line, and you can also use IPython in your browser. Let's see, we have a bit of an issue. So when I'm using IPython Notebook, I go to the command line and I just put IPython Notebook, and it will give me the instance of my notebooks. There we go. All right. So we begin with importing our packages. And I'm going to display the different flowers, just in case you want to see the irises again. And in this example, we are going to set our nearest neighbors to 20. In this section, we are importing our data set, which are irises, and target means that these are the labels for our data set, since we're doing a classification. I'm printing the shape of X. This actually tells us how many testing points that we have. Training points, excuse me. Here, we're actually making our mesh. For the we're going to actually have two plots. Our plots are going to be uniform and distance in terms of majority vote. This is our estimator, and our estimator, we're creating an instance of neighbor classifier and fitting the data. We are creating the minimum and maximum of our x and y axes. Finally, we're predicting our training data, and we're going to create the mesh. And this is what we get as a result. So in figure 1, our weight is uniform, which means that each training point is equally counted. And for distance, our training point is based on the distance to the testing data. So as you can see, our decision boundaries are different. In order to illustrate and bring home the importance of the majority vote, why don't we run this again? And in this case, we are going to set our nearest neighbor from 20 to 150. And remember, 150 is the amount of training data that we have in total. So we're running the data. So for a distance, our decision boundaries are more or less the same. However, if you look at the majority vote for uniform, our decision boundaries are gone, and we just have red. The reason why we have red is because instead of using distance, it actually looks at the amount of training data we have. We mostly have red training data points, and that influences our decision boundaries. The great part about IPython is you can play around with the parameters, and it just gives you different results, and it gives you a more robust way of analyzing your training and testing. So that is it for my presentation. We can have questions. Oh, thank you.
All right, for any questions, please come to the microphone in the middle and just line up.
Hi there.
Hello.
Just some basic methodological questions.
Okay.
So you mentioned two things. The number of neighbors you're looking at in making that judgment of classification. What's the criteria to determine how many neighbors should be picked? That's the first question. And you also mentioned the risk of overfitting when too many parameters are introduced. So is there any criteria or tests that can be done to assess this risk of overfitting?
Well, the Scikit Learn package has excellent documentation on this, and what I did not do in my talk is I did not talk about validating your data. So once you're finished running your algorithm, I think the best way to deal with this issue of your overfitting is to validate the data and test the accuracy.
Hi, thank you for the talk. I noticed in your results slides that the decision regions were discontinuous. I was wondering if you could talk a little bit about why that was and whether that's a feature or a bug.
I'm sorry, that was not a feature, that was a bug. And we can talk more about it after the talk. I can tell you about how I got the data and how I analyzed it, and yeah, I'll get into more detail afterwards.
Thank you.
Really enjoyed the talk. Was wondering if you could talk about some of the real applications you're working on right now using machine learning.
The real applications that I'm using machine learning for, I do a lot of natural language processing. So I'm using natural language processing to help assist with search. Okay.
All right, any more questions? All right, please give a hand. Oh, you.
I couldn't quite read the code that you were showing, but is that k-means that you ran with k and n?
No, no, that's just k and n. Because k-means is clustering, and we're doing classification.
Okay, I thought you were clustering S3 things into one.
Oh, yeah, no.
Okay.
Any more questions? All right, please give a hand for Portia.
Okay.